Alright, so in this video I'm going to be explaining how to do step 2 of VR. So this is actually the first time we get, I mean not the first time, but this is actually the step where you actually have to pick up the cube. If you notice from the previous video, we actually did not have to turn the cube at all, except for figuring out the ending final slice state. That's the only thing we need to do. We could just figure out all the VRs from paper. Here we actually have to pick up the cube, which is not gonna really work super well with this format, so I'm just going to ask you that you follow along. So it's not even that much to follow along, because really all we are gonna have to do is go to the initial slides, the initial state, and then perform the VR, and then just sweep across the VR, just going to various points of each VR. So I mean, it doesn't matter that if you miss, for example, something in the first one when I explain what happens in the second one, because it's the same thing. But yeah, so the first thing that I'm gonna have to do before doing this explanation is explaining what the possible slice states at this point even are. So we're gonna have 4 possible slice states, and I'm gonna be labeling this with R, F, G, and there is one last, which is actually, I guess I can call this 0 or T. In my doc I call it T for whatever reason. Actually, no, let's be consistent. T, which stands for dots. And there's 8 if you remember, which depends on the centers, which we're gonna go through this real soon. So the R slice state is a 2-2 swap, which is like this. So FR is swapped with BR, and FL is swapped with BL. And if you notice, one of the swap is across the R phase, which is why I call this R. I think you understand what F means. This FR with FL, BR, BL. Notice it's a 2-2 swap. So that's the same thing. Okay. G is diagonal. Okay, G is the last letter in diagonal, which is why I called it G. This is this swap. Okay. And this is a no swap. Okay, T is the last set of dots, because if you have the dots, like from Rule L6E, I guess, that's a dot. Well, although it depends on the centers. So the final thing is that plus refers to sol centers. This isn't the plus minus thing isn't something that I came up with. It was Complex was the one who came after it to come up with it. So shout out to Complex on Discord server. And minus is unsolved centers. Friendly reminder that centers are only ever allowed to be off by E2 or nothing. Right? So with that said, let's actually we will see why actually I've developed this notation. So now what I'm going to be doing is, as usual, I'm going to be executing this purple. I'm going to take a solve cube. I'm going to be executing this purple sequence, and then I'm going to undo this. L2, you can't see that. F2 D prime, L2 U prime, D2 D, R2 F2 U2, F2 U prime, D2 U2. And now let's just execute the first VRN plus 0. So U2 D2 U wide, F2 U2, F2 R2 D wide prime, D2 U L2 D F2 L2. Okay, what is the swap? You might think it's R, but it's not, because you actually have to look at this relative to the U and D layers, and the centers actually are wrong here. So this is actually an F swap. The centers are unsolved, so this is F minus. I'm gonna label it like this. I don't usually write it down in this manner. I just kind of write F minus next to this, because there's no way this can be confused. But yeah. Now, what I'm gonna be doing is I'm going to go through different spots of the skeleton and write down what edges would be swapped by an E2 insertion. And we only need to look at 2 of these, because here are 2-2 swap. So, yeah. So with this cube from F minus, I'm just going to be doing L2, F2, and I'm going to stop at U and D moves. Really, at the first sweep, you can just stop at U2 moves, because if you were to insert an E2 on the D, that would add 1 move, and you want to check plus zeros before plus ones, right? So yeah, but I'm going to do this just so that you understand what's going on, I guess. Well, no, actually. But okay, let's just swap right here. Did I say swap? I mean stop. So you notice how on FR and on BL you have two red edges, which will be swapped. This corresponds to the R swap. And if you look at the other two edges, they're orange edges. So an E2 would be performing an R swap here. We don't need to check the right data minus because an E2 swap centers. That's how an E2 works. So yeah. Thank you for coming to my TED Talk. So this is R. I'm just going to be writing it like here. Now let me go to the U, so let's do D prime L2. And here, well, here, if you look at FR and BL, they share no color, so this is actually the G swap. U prime V2, you have two blue edges, which is an F swap because the other two are green, right? So actually, we found a +1 already, but actually that could be better from there. And in fact, there is spoiler alert. So let's do D wide R2 F2, and here we have two orange edges, so this is an R swap. U2 F2, we have edges that share no color, so this is G. U wide prime B2, and these two are blue, so actually, yeah, this is F. And notice that if we insert an E2 here, we actually cancel 2, so this is a +0. So actually already found a +0. So, so if we undo the U2, we are back at the beginning of the skeleton. And so we found our final solution, which is U wide 2, B2, U wide, F2, U2, F2, R2, D wide prime, B2, UL2, D, F2, L2. Now, in this case, we were lucky because we had a non-trivial swap of edges with unsub centers, which can always be done with one swap. And actually, this is pretty much the only way to do this optimally, because otherwise you're just adding extra E2 swaps, which cannot decrease the move count. I will explain this better later, but yeah. So now let's just execute the purple sequence again. So B2 U D prime R2 U prime D, and undo this again. And I mean, okay, we wouldn't need to do this because like we already found the +0, but I'm doing a tutorial, so let's just do the second VR as well. So 2U F2 U2 F2 R2 D Y prime D2 U Y L2 D F2 L2. Okay, here we get R minus. And you can, okay, let's actually just quickly go through this again. So L2 F2, this is R. So actually, like, we already found +1 from here. Well, I meant to write this in purple. D prime L2, this is diagonal. Uy by prime D2, this is orange. Dy R2 F2, this is green, so this is F. U2 F2, this is G. U prime B2, and this is F again. Yeah, you notice how this is not affected by anything that happens after this. I wouldn't even be writing down these purple things I'm writing actually. Yeah. So okay, so now we have done this. So this VR is actually up to U +1. Let's look at the third VR. B2, B2, U, F2, U2, F2, R2, B2, U, L2, DY, L2, L2. This is more interesting because now this is actually R+. So how do you get R+? So now here we're lucky because we only need one E2 insertion. Here we're going to need 2. So I'm just going to be making a quick table. So you have the edge permutation, the centers, and so this can be T, F, R, G, and this can be plus or minus. So this is solved. Here you need an F, an R, and a G in any order. So one thing that I haven't told you is that these elements of the field group, they combine them in a manner that respects the law of commutativity. So that's very good because it means you don't have to worry about any order. Okay, so this is F, this is R, this is G, and here, well, what you want here, you actually want R plus G, F plus, so the other two basically, you need R plus F. Okay, and actually that's the only way to do these in a way. That's not quite true. You can add more slices, but adding more slices cannot decrease the move count, as I explained before. So really, that's the only thing you should be looking for. So if you have F plus, you have to look for an R and a G. So let's just do this real quick. So let's do L2 F2. We got R. We don't want that actually, but I'm gonna write this anyway. dy prime L2. That's F. dy prime B2. That's R. dr2 F2. That's F. u2 F2. That's G. u prime B2, and that's F again actually. So I guess the optimals, like we get a +1 by, for example, widening this U2 and adding U2 here. So this would be like U2, B2, and then something like U prime UY2, U2 UY2, F2 R2, E prime U2 U2. Yeah, it works. So this is how this works. Let's actually do the exercise of looking at this VRM +1. The reason this is interesting is that now inserting E2 here is actually a +0. Which, yeah, it sounds weird, but that's true actually. So you can have a +0 if you insert on U2. You can have a +1 if you insert on U, or like U wide, D wide. And you can have a +2 if you insert, well, nowhere. But you can also have a +0 if you insert here. Okay, because you're just turning this U wide U into a U wide prime U prime. Okay, remember this is the same as U2E. So if you insert an E2, this is the same as UI2E, which is still 2 moves. Yeah, because one of the, like, I shouldn't have to explain this. It's 2 moves. Says I shouldn't have to explain this. I'm making a tutorial. Okay, let's go back. Do this purple sequence. So B2D, undo the skeleton. And let's just execute this VRM +1. Q1 F2. So here we get, this is F minus again. And yeah, let me just jump. Let's do this as I would do in the real solve. I just ignore anything that's not in F. So U prime. This is F. B2 D wide. I'm gonna switch mode. R2 F2. This is R. I'm just gonna write the fact this is R, but yeah. So if this had been an F, this would have been a +0. So we get G, and this is F again. So we got a +0. Well, it's a +0 but +1. So that's again that's +1. So this is how you find +2, and you see how really easy that is. Like there's no backtracking required. I mean, there's the backtracking is just to switch from a VR to another one, but once you're in a VR, there's no backtracking required. There's no brute forcing required. You need to check, like, you know what you have to check for. Like, that's the table. If you have F plus, you need to check for an R and a G. That's it. And you check for like the R and the G that are the smallest in move count, like the smallest in cost. That's it. So I guess the next video is going to be a theory maximum where I explain the mathematics behind VR. So yeah, see you there.